Now we are going to discuss about decision tree. Decision tree is basically a tree-shaped diagram, as you can see, which shows graphical representation of a problem with all the possible solution to a decision. All decisions are based on some conditions, which is used to determine a solution for a problem. Now, problems that can be solved with the help of decision tree are, as we have studied about, the regression problems, and also the classification and logistical problems. Decision tree belongs to the family of supervised machine learning algorithm. That means having a predefined target variable that is mostly used in classification problem. Decision trees often mimic the human level thinking. It's so simple to understand the data and make some good interpretation also. Now we will discuss about some decision tree terminology with the help of this diagram. So first thing that I want to discuss is entropy. Now this entropy is a measure of the randomness or unpredictability of the data set. Entropy basically measures the error of the model. Next we come to information gain. Now this information gain is based on the decrease of entropy after a data set is split on an attribute. Information gain is the difference of the error in the root node and the leaf node. Here you can see the root node and the leaf node, also known as terminal node. Now, root node is basically problem which we are going to solve. This is actually called the root node and can be said the problem which we need to solve, and it is on the topmost of the tree always. Leaf nodes are nodes that can be further divided into nodes. That means it is the final node. Let's say this terminal node is actually a leaf node. That means it cannot be further divided. Terminal means the end. Splitting it, dividing the root nodes into subnodes. That means here has happened splitting, where you can see that root nodes are further divided. Branches formed by splitting the root nodes into nodes and further nodes into the subnodes. So these can be said the branches. Like we have the branches of the tree, similarly these can be said as the branches of the decision tree. Now here you can see a decision node. When a subnode split into further subnodes, then it is known as decision node. That means this particular node has further on splitted, this node has also splitted, and this terminal node has also splitted. So these, when the subnodes are also splitted and the nodes derived by them are known as the decision nodes. Next is the parent or the child node. All the top nodes are parent nodes, derived by them are the derived nodes or the child nodes. So it can be said that this is a parent node, this is also a parent node, and this is also a parent node. And all the terminal nodes which are derived are known as a child node. Next we come to pruning. Now pruning actually is the opposite of splitting. That means removing the subnodes from the decision tree. Basically removing the unwanted nodes or branches is known as the pruning. Now here you can see that it is also a branch, a separate branch it can be said. Or also can be said a subtree. So if we prune this or if we remove, if it is not required in our algorithm analysis, then it is known as pruning. That means removing the unwanted nodes and the branches. Now this is actually can be said that A is the parent node of B and C. Here you can see if we call this decision node as A and this is B and C, then it can be said that it is the parent node of B and C. Now we are going to discuss about the advantages and the disadvantage of the decision tree. So the advantage of the decision tree is that little effort is required to prepare the data. So that is the advantage, and it is easy to generate the rules. Next are the disadvantage, that is overfitting occurs when the algorithm captures the noise of data. Model get unstable when small variance of data is added. Pruning is necessary for large set of data. If you have large set of data, then obviously it needs to be pruned. Also, cannot create the biased learned tree if some classes are dominant. Not fit for continuous variable. So decision tree is not fit for continuous. So this all sums up for the decision tree, and in our next video we will make a decision tree of the iris dataset which we used for the logistic training also.